Welcome back to part 2 of permutations and combinations. In the previous video, we learned the basics of arrangement and selections. Today, we move further and explore three very important topics: factorial, circular permutation, and cases with repetition. Let's begin. Before we continue, let's quickly revise. Permutation means order matters. Rearranging letters or digits make different arrangements. Combination means order does not matter. We focus only on selection and we use the formulas NPR and NCR to calculate them. With this foundation revised, we are ready for today's concepts. To calculate arrangements, we use factorial. For example, 5 factorial written as 5 factorial means 5 into 4 into 3 into 2 into 1. So 5 factorial equals to 120. A very important point to remember: 0 factorial is always equal to 1. Factorial is the backbone of permutation questions. Moving to circular permutation. Now comes circular permutation arrangements around a round object like a circular stage, necklace, or dining table. Because there is no left or right starting point in a circle, the formula changes to n minus 1 factorial. For example, 5 people seated around in a round table can be arranged in 5 minus 1 whole factorial equals to 4 factorial equals to 24 different ways. Circular permutation with restriction. This becomes more interesting when there are conditions. Let's take an example. Four boys and three girls sit around a circular table, but all the girls must sit together. So we treat all three girls as one single group. Now total groups become 5. So arrangements are 5 minus 1 factorial equals to 4 factorial. But inside the group, the three girls can rearrange themselves in 3 factorial ways. So the final answer becomes 4 factorial multiplied by 3 factorial. This method makes restricted circular setting very easy. Moving to the repetition cases. When items repeat, total arrangements reduce and we apply n factorial divided by factorial of each repeated item. Let's take an example: the word banana. Total letters equals to 6. That becomes 6 factorial. But the letter A repeats 3 times, that becomes 3 factorial, and N repeats 2 times, that becomes 2 factorial. Therefore, the number of distinct arrangement becomes 6 factorial upon 3 factorial multiplied by 2 factorial equal to 60 unique words. Let's solve a typical exam question. How many four-digit numbers can be formed using digits 1, 3, 3, 5, 5? Total digits 4, that becomes 4 factorial. Repeated digits 3 appears twice and 5 appears twice. That becomes 2 factorial multiplied by 2 factorial. So the number of distinct 4-digit numbers will be 4 factorial upon 2 factorial multiplied by 2 factorial equals to 6. This is a very common formula based question. Don't skip it. Now it's your turn. Try these two words using the repetition formula. Number of distinct arrangements of the word success and the word Google. Write your answers in the comments. I will be checking them. If you want part 3 of permutation and combinations, where I will teach shortcuts, tricks, and previous year questions, comment below permutation and combination part 3. And don't forget to like, share, and subscribe. Your support helps me to continue making useful learning videos. See you in the next one. Thank you.